welcome. Let's try to solve another Leetcode problem, 922, sort array by Parity 2. So for this problem, we are given an array of integers nums. Half of the integers in nums are odd, and half of them are even. So what are we going to do? So we're going to sort the array so that whenever nums I is odd, so whenever this number is odd, so the index should also be not. So whenever this number is even, the index should also be even. So we're going to return any answer arrays that satisfy this condition. So let's just check. So there's going to be a follow-up. The follow-up is that could you solve it in place? So this is definitely in place algorithm, and normally it's going to be much harder than we are using some extra space. So for this problem, what about if we are using some extra space? It's going to be much easier. Yeah. So let's just prepare two arrays. Let's just call it maybe just even and odd array. Yeah, because we just want to put the numbers inside and get the final result. Yeah. So how can we get the final result? Let me put it as a result. Yeah. So because there are the same number of even and odd. So let's just write like this. So for AB, just two numbers inside shape of even and odd. Now we just want to put it inside. So result dot extend array with this A and B, and finally we're gonna return this result. Yeah. Now we just need to put the numbers with even and odd. So for n inside nums, if n modular 2 equal to 0, we want to put it inside the even array. Else we want to put it inside the odd array, right? Yeah. So the odd array gonna append this number. Yeah. Now we finished the basic pattern, and let's just check that and submit it. Yeah, as you can see, we used some extra space. This is not good. Yeah. Yeah, because according to, as you can see, it works. According to the zip, we're gonna first zip the even and then the odd. Because the length of the even equal to the length of the odd, definitely we're gonna put even, odd, and it's gonna be the same as the index. It should be okay. But this is not what asked in a real interview. Definitely, this is not okay. We need to solve the problem in place. So normally, if we want to solve the problem in place, definitely we need to use some pointers. It may be two pointer, yeah, or it may be a sliding window, or it may be something else, or it may be list groups. Yeah, and for this problem, it's going to be a two pointer. So the idea is that we're going to check the numbers one by one. So for example, we have 4, 2, 5, 7. Yeah, we always want to find what's going to be the first number which didn't meet the condition, and what's going to be another number. So for example, we found a number A which didn't meet the condition, and another number B didn't meet the condition. So the condition is that, so for this number A, it should be the even number, but this is odd, and for this B, it should be an odd number, but this is even. Yeah, so this means the number A and B gonna have a swap. Yeah, so this means the number A and B have a swap. So how can we find this easily? We're gonna find the first A and first B, second A and second B. Yeah, and we're gonna find the first A with the first B, and then we're gonna swap. And we're gonna find the second A, second B, then we're gonna swap. Yeah. Now let's just check one by one. So for example, we're gonna set a pointer from the left side. This pointer gonna be I. So it's going to be an even number. It is okay. It is even number. But how can we find the... so for this I, we're going to set it with the even indexes. So for this number 4, it is okay. And what about this number 5? This is not okay. Yeah. So this means the I, for the next time, the I going to be shifted to here, because the I going to always be the even index. And we're going to prepare another index J. This J going to always be the odd index. So why we're going to do this? This is the most difficult part. Otherwise, we cannot solve the problem. Yeah, because this is really difficult while we are thinking about in-place algorithm. We have to try a lot of pointers, try a lot of testing cases, or maybe this is okay, or maybe this is not. Yeah, because this is easier. So for this index I, it's gonna always be the first first odd number. Yeah, because this index I, definitely we need to have the even number, but we're gonna find the first odd number, so which is this number 5. And for this index j, we're gonna always find the first even number, because the odd number is okay. So this is the first even number. So this means this 2 and 5 are gonna have a swap. So after swap, it's gonna be 5 and 2, and this is gonna be the final answer. So it's gonna be 4, 5, 2, 7. So this is the basic idea. Yeah, because our solution is that we're gonna always find the first. So we're gonna try to always go from the left side. Because if you go one from the left side, another go from the right side, how can you make sure it's gonna be the first number, first even number, or first odd number that we're gonna swap? So we have to go to the same direction. We're gonna always go to the left, or we're gonna always go to the right. Yeah. So for easy writing the code, we're gonna always go to the the direction should always go to the left, and this way gonna be easier. Yeah. So now let's just start coding. So we're gonna prepare two pointers I and j. So I gonna be the even pointers, and j gonna be the odd pointers. So it's gonna be 0 and 1. And we're gonna check with I. So while I less than the length of the nums, so we're gonna check if nums I is even, so everything is okay. So we're gonna update the I, because I is for the even pointers, we're gonna step by 2. And similarly, if nums j modulo 2 equals 1, so for the pointer j, it's gonna be step by 2. Else, yeah. So this means we found something to swap. So this means this number at index I, it is odd. This number at index j, it is even. Definitely we need to have a swap. So the swap gonna be the nums I with nums j, gonna equal to nums j with nums I. And after that, we're gonna do the similar step. I and j, gonna update it to 2. And finally, we're gonna return the numbers. Yeah. Now let me just run it. Now as you can see it works. Now let me just submit it to check. Yeah, as you can see it works, and it passed for all testing cases, and the space complexity is just 1, and the time complexity is O(n). Yeah, so the difficult part about this problem is that sometimes it's really difficult to find a solution, especially for the in-place algorithm. Yeah, we have to try the different testing cases, because for this one, this is I and this is j. So no matter whenever this is I or this is j, or maybe I is here, or maybe I is here, or maybe j is here, definitely we're gonna do a swap. Or maybe I is here and j is here. So after one pass of the while check, definitely we finish all the swapping. Yeah, I think that's all about it. Thanks for watching. See you next time.